Hey everyone, I'm Brandon Graisley. I'm a high school math teacher, and I'm going to do something a little different today. I have this page already prepared, and you can download it in the comments down below, or if you're in one of my courses, I've probably posted it for you wherever we do our course stuff. And we're going to learn about how to define trig functions using the unit circle instead of just using those old triangles that we used when we started this maybe in grade 10. So up until now, we've been using this SOH CAH TOA strategy. Sine, cosine, tangent are opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. That's the strategy we've been using the side lengths of right triangles. But as you can imagine, that kind of breaks when you get to angles that are 90 degrees and larger, or even 0 degrees, because right triangles don't have those angles. Instead, we're going to use what's called the unit circle, and we're going to redefine these functions. We're going to use angles in standard position, and this strategy will work for any angle, even very large ones like 1,000 degrees, or very, very small ones like negative 20 degrees. So grab this page and let's start working over here on the unit circle to define these. So we're going to start by constructing an angle. We're going to call it theta in standard position with a terminal arm in quadrant 1. So this will look like the ones that we're used to. So I'm going to draw an angle like this. That's my terminal arm. The angle itself is called theta. And we want to notice where the terminal arm for that particular angle intersects the unit circle, right there. And we're going to label that point x, y. We'll be using those coordinates in just a moment. We're going to construct a right triangle by dropping an altitude to the x-axis. So an altitude is a vertical line from this vertex straight down to the base. Like that, and it forms a right angle with this base, which is the initial arm. So now you see we have a nice little right triangle, and the angle theta is one of the angles of that triangle. So this is pretty cool, actually. Let's look at the lengths of these short legs here. This leg has a length y. The x-axis has a y value of 0. This point has a y value of what we've called y. And so this length is y. Horizontally, there's 0, 0 at the origin. Moving in this direction, we get to this spot here, which has the same x-coordinate as that point. So this side has length x from there to there. Maybe I'll put a little measure-y thing here to make it easier to see. So that's x, and that's y. Now, using this, we can actually use these letters x and y to come up with the primary trig ratios. Well, there is one more thing that we need, and that's the length of the hypotenuse. Remember, I called this the unit circle. It's called that because this circle has a radius of 1, the word unit meaning 1. So up here you see that coordinate is 0, 1. This one over here is 1, 0. And anything else, like let's say this line from the origin to the circumference, this is a radius. It has a length of 1 as well. Okay, let's head over here to the sine ratio. We remember that the sine ratio is the opposite side length, which in this case is y, divided by the hypotenuse side length, which in our case here is 1. So we can just say y. For the cosine, adjacent side length is x. Hypotenuse is 1, so we can just call that x. And last we have the tangent, which is the opposite side length, y, divided by the adjacent side length, x. So now, if we know the coordinates of this point, that tells us the sine of that angle, the cosine of that angle, and with a little calculation, the tangent of that angle. So we're going to extend this definition for any angle, not just for the acute ones that show up in this first quadrant. So in the other quadrants, 2, 3, and 4, that's the Roman numerals for 2, 3, and 4, some of these coordinates are going to be negative because we're not really going to use the side length x. When we have a point that's over here that has a negative x value, we're going to use that negative x value in place of the length. Okay, let's see what that looks like. All right, so let's look at some larger angles. For each of these angles here, we've got 4 of them. We're going to find the intersection point of the terminal arm with the unit circle. We'll do that by calculating the sine and the cosine of each angle, and we're going to draw each one in standard position. So let's start by drawing, grab pink here. We'll start by drawing 120 degrees. 90 would be up here, 180 is on this side, so 120 is about here. There's the intersection point. Now to calculate the x and y coordinates of the intersection point, we can find the sine and the cosine. Now cosine gives us the x value and sine gives us the y value. I'm going to grab a calculator. Let's check this out. Cosine of 120 degrees. Oh, looks like negative 1/2. And let's find the sine of the same angle. Oops. √3/2, or about 0.866. So, and that was a positive number. So those are the coordinates of that point right there. Maybe I'll write them on the diagram. Okay, so that is going to help us out a little bit later on. So for now, we're just learning how to make this connection between the angle, this point, and the sine and cosine of that angle. Okay, let's go on to the next one. 210 degrees, this is an alpha. 210 is a little bit past 180. 180 would be here. So we're finding that point using sine and cosine. Once again, x is going to be the cosine of that angle. And y is going to be the sine of that angle. So cosine of 210 negative √3/2. Which will be about negative 0.866. And sine of 210, negative 1/2. Interesting that those are really similar numbers. Okay, well, let's write that down. So the x value is a negative number as expected, because we're over here in this quadrant. And the y value is also negative. Okay. This one is a delta, 340 degrees. That's over here. Start by finding the x value. So I'm expecting the x value to be a positive number now since we're on this side in the fourth quadrant. So if I do cosine of 340, I'm expecting a positive value. Okay, we didn't get a nice square rooty thing, but we've got about negative 0.940. Sorry, I said negative 0.940. It's a positive number. And the y value, sine of 340 degrees. Now this one should be negative since we're in the fourth quadrant, which is below the x-axis. Sine of 340, negative 0.342. And those are both approximations. Okay, so let's write that down. Okay, last one. This is a gamma that looks kind of like the letter Y, but it's a gamma. 500 degrees. Well, let's talk about this for a moment. Because this is more than 360 degrees, we start our standard position angle from the initial arm. We go a full rotation. That's 360. If we keep going, another 90 would be over here. That's 450. And another 50 degrees past that would be about there. So we've gone a full rotation, and then we're kind of over in quadrant number 2 here. So let's see what we ended up with for this angle. The x value is the cosine of 500 degrees, and the y value is the sine of 500 degrees. Cosine of 500 is about negative 0.766. And I was expecting a negative x value, so that's good. And the sine I expect to be positive since that's our y value. 0.643. Okay, let's write those down. Okay, now just before we finish this up, I want to notice that this terminal arm is up here in quadrant 2, and there would be another angle with the same terminal arm. This 500 degrees is 360 plus another 140. And let's see what happens if I type in the cosine of 140. Yeah, sure enough, it's the same number, and the sine of 140 also the same as the y value that we got here. So the terminal arm is what decides what the sine and cosine are and decides this intersection point. And so the sine and cosine of 500 are the same as the sine and the cosine of 140. And we're going to use that fact later when we are solving trigonometric equations. Okay, let's start working on using the unit circle to find the primary trig functions for each of these angles. 0, 90, 180, 270, and 360. So I've got a whole bunch of little unit circles drawn for you here, and we're going to figure out the sine, cosine, and tangent of each one. We do this by drawing the angle in standard position, noting the x and y value, and then making our calculations down here as necessary. So let's start with, we'll start with 0. That's fine. We'll start at the far left here. 0 degrees drawn in standard position looks like this. And it intersects the circle right here, and that point is 1, 0. So the x value is 1, and the y value is 0. Remember from before, the sine of theta, our angle 0, is the y value. Let me just write that right here in the little corner. The cosine is the x value, and the tangent is the y value divided by the x value. So sine of 0 is the y value. The y value is 0. So this is just 0. We couldn't do this before when we had triangles because we couldn't have these side lengths for a triangle that was, sort of flat and not a real triangle. The cosine is the x value. In this case, that's 1. And the tangent is the y value divided by the x value. In this case, that's 0 divided by 1, which is fine. That's just the number 0. So sine of 0 is 0, cosine of 0 is 1, tangent of 0 is 0. Let's go on to 90 degrees. In standard position, starting at 0, going up to there, that's 90 degrees. The y value, where the intersection happens, is right here. It's at, I should write it on the screen for you. It's at 0, 1. So the y value is at 1. So sine of 90 is 1. The x value gives us the cosine. That's 0. And for tangent, we take the y value and divide by the x value. So that would be 1 divided by 0. Now hopefully alarm bells went off in your math brain right now, because this is not allowed. We can't divide by 0 because this is undefined. That means there is no tangent for the angle 90 degrees. That's not allowed. So don't try to do it. That one is not okay. This one is fine. This one is not fine because it's dividing by 0. Let's keep going. 180 degrees. That's halfway around the circle, starting up there. There's my terminal arm. There's the intersection point at -1, 0. So -1, 0. X value -1, y value 0. The y value tells us the sine. So sine of 180 degrees is 0. The x value tells us the cosine. Cosine of 180 degrees is -1. Notice that it's negative. Tangent of 180 degrees, let's take the y value, 0, divided by the x value, -1, and that's just 0. You might see a pattern forming here. 270. Starting at 0 all the way around to there. That's 270 degrees. Intersection point here at 0, -1. So hopefully it's getting a little bit faster for you now. The y value is -1. The x value is 0. And then we have the y value divided by the x value. That is sine over cosine. -1 divided by 0. Once again, that is undefined. There is no tangent for the angle 270. Now let's check out 360. Start here, all the way around, full rotation, getting back to where we started from, 360 degrees. The terminal arm is there, goes through that point. That point is 1, 0. The y value is 0. The x value gives us cosine, that's 1. Then we take the y value and divide by the x value to get the tangent, and that's just 0. Now notice that we have exactly the same values for 0 and for 360. Now this is a key understanding here, because these two angles, even though the angles are different numbers, they have the same standard position. They have the same terminal arm, which means they have the same intersection point with the unit circle. The unit circle intersection point is what determines the trig ratios. So every angle here, here, and all the other ones like them, every angle that has the same terminal arm has the same numbers for the trig ratios. So these are predictable as long as you can figure out any of the ones between 0 and 360. You can also figure out any of the ones that are larger as well.